You know when your favorite app perfectly predicts the exact song you want to hear next? Or when a platform serves up an incredibly well-timed ad that just makes you think, how did they know? Well, you're experiencing the output of a massive invisible engine running quietly in the background. That engine is data. And honestly, it literally dictates the modern digital experience. But here's the thing. Raw data is just digital noise, right? It's completely useless until it's actually processed. So today, in this explainer, we're going to demystify exactly how that messy, chaotic information is transformed into powerful, actionable insights using Python's ultimate data stack. We're essentially handing you the keys to the kingdom, breaking down the exact pipeline the world's biggest tech companies use to make sense of our world.
So here's the game plan for our journey today, and it's beautifully simple. First, we're going to cover core Python fundamentals, kind of like establishing the basic grammar of our data language. Next, we shift into high gear with NumPy for the heavy mathematical lifting. Third, we organize all that numerical chaos using Pandas. And finally, the fun part. We bring it all to life visually with Matplotlib. Let's jump right in and build that foundation.
All right, part one, core Python fundamentals. Think of coding syntax a bit like casting spells. You absolutely have to learn the basic alphabet and those beginner incantations before you can write a novel or, summon some real data magic. In Python, reality is categorized into these primitive building blocks. We've got integers, floats, strings, and booleans. They're the basic tools in our tool belt. But the real magic happens when we group them into scalable structures, like lists and dictionaries. Think back to that music recommendation engine we just talked about. An integer might track a user's age, a string holds the artist's name, and a boolean, well, that just flags whether they have a premium subscription or not. This is literally the DNA of every complex data set you've ever interacted with. Okay, let's dive into this a bit more. We map these human concepts to machine memory using simple variable assignments. By simply telling Python that X is 10 or name is Ali, we are abstracting complex, real-world data into readable logical buckets. And this readability, it's a real game changer. It's exactly why Python completely dominates the data science landscape today. You aren't writing arcane, unreadable machine code. You're writing structured logic. A brand new developer can jump into a code base and almost instantly understand exactly what data is flowing through the system. Now it's time to drastically speed things up. Welcome to part 2, number crunching with NumPy. If standard Python is a super reliable bicycle, NumPy is a Formula One car. Picture this. Imagine trying to analyze 1 million user profiles using a single, flat, sequential list of numbers. It'd be an absolute architectural nightmare, right? Well, NumPy actually solves this by instantly snapping data into multi-dimensional matrices, rows and columns. This grid architecture is exactly how machines natively think about and process massive real-world environments. An image, for example, is really just a 3D matrix of pixel color values. Structuring data this way unlocks exponential computational power. Because NumPy relies on C-language architecture under the hood, it can perform mathematical operations up to 50 times faster than standard Python lists. 50 times! And instead of painstaking manual data entry, a single line of NumPy code conjures up a complex, randomized 3x3 matrix in milliseconds. Why does this matter to us? Because whether you're initializing starting weights for an AI neural network, or maybe running Monte Carlo financial simulations for a massive hedge fund, you need huge arrays of structured randomness on demand. NumPy generates it flawlessly every time. And this is where the heavy lifting actually happens. Finding the mean or standard deviation of a dataset with, say, 10 million rows, that would outright crash a traditional spreadsheet application. But the crucial point here is that NumPy processes it instantly, using these built-in, hyper-optimized mathematical functions. What would literally take human analysts weeks to calculate by hand, NumPy crunches for millions of data points in a fraction of a second. No sweat. But, raw matrices and blistering fast math, they lack one crucial element: human context. And that brings us perfectly to part 3, organizing data with Pandas. This is where we act as the organizer, bringing structured calm to all that mathematical chaos. Pandas solves the whole readability problem by wrapping those abstract arrays into what we call data frames. It gives us the beautiful, familiar structure of a spreadsheet, but it's supercharged with Python's deep logic. So now, a seemingly random cluster of integers and strings instantly becomes Alice, the 24-year-old HR employee making $45,000. See how that works? It perfectly aligns raw computational power with actual human business logic. Think about traditional data wrangling in a normal office setting. If you wanted to filter out employees by a specific age range, group them by department, calculate their average salaries, and then, I don't know, apply a uniform 10% bonus across the board, doing that manually takes endless clicking, dragging, and dealing with incredibly prone-to-error formulas. But Pandas condenses that entire exhaustive workflow into 4 elegant lines of completely reproducible code. It's doing in seconds what takes 10 minutes in Excel.
And the result? Instant aggregation. Pandas effortlessly scan the data, grouped our specific HR team members, and delivered the exact calculated average of 46,000. To put that into perspective, in a real corporate database containing millions of global employees, executing that single logical action saves countless hours of manual computation. Plus, it entirely eliminates the risk of human error.
Okay, so we've done the heavy math, and we've organized the numbers logically. Now for the real, ta-da moment, Part 4, Visualizing Data with Matplotlib. This is basically the ultimate canvas for translating all of our hard backend work into clear, persuasive human communication. Let's be real, humans are notoriously terrible at reading raw data tables. Our brains simply aren't wired to quickly extract insight from massive grids of text. But we are absolutely exceptional at spotting visual patterns. What's really interesting here is that by feeding a simple dictionary of student marks into Matplotlib, it instantly generates a clear comparative bar chart. Your brain immediately registers Bob as the high achiever, magnitudes faster than analyzing those raw numbers in a column. It completely bypasses the analytical strain and delivers the insights straight to our visual cortex. And that exact same logic applies to communicating global business metrics. A dense block of text outlining regional revenue splits is practically guaranteed to put a corporate boardroom to sleep, for sure. But just a few intuitive lines of Matplotlib code can create a dynamic donut chart, complete with a subtle exploding slice effect to really highlight North America's market dominance. It takes abstract regional data and transforms it from merely being informative to being immediately persuasive. You're no longer just showing numbers, you're telling a compelling, clear visual story. So what does this all mean? Well, from the foundational grammar of Python syntax to the hyperspeed mathematical engine of NumPy, through the organized, human-centric structure of Pandas, and finally, the persuasive visuals of Matplotlib, you've just seen exactly how code tames chaos. This is the exact pipeline driving the algorithms, the recommendations, and the insights shaping our entire digital world right now. The invisible engine is officially in your hands. The only question left is, what will you build with it?